do the left column all the way down here. Whoops. Hold on, my pen's not working. All right, I got everything under control now. I'm going to go pretty fast, so feel free to pause this whenever you want to. All right, the first thing that we're going to do here is 634, number 47. This 660 that's right here, you can do that tomorrow, all right? So this is the first problem. We have a tee box that's 48 feet above the fairway, starting with initial elevation of 48. So the 48 is going to go here on the end. An initial velocity of 32 feet per second. We have to find, first of all, by factoring to see how long the ball is in the air. So I'm going to do this up here, my negative 16, because they're all divisible by negative 16, and that gives me t squared. That's going to be a minus. This gives me t squared minus 2t minus 3. Continuing to factor, I've got negative 16, t minus 3, and t plus 1. This is equal to 0. The t minus 3 will give me a solution of 3 seconds. The t plus 1 will give me a solution of negative 1 second. I can't have negative 1 second, so the total time that the ball is in the air is 3 seconds. Now we need to find the ball at 1 second. So I'm going to take the original problem, negative 16, and I'm going to plug in 1. 1 squared plus 32 times 1 plus 48. That gives me negative 16 plus 32 plus 48. 32 and minus 16 is 16 plus 48 is 64 feet in the air. So B is 64. C is the ball at its maximum at 1 second. Well, I'm going to have to do negative B over 2A. So this is C right here. Negative B, I'm going back to the original, is 32, so that's going to be negative 32 over 2 times negative 16. That's 32 divided by 32, and the time is 1. Yes, it's at its maximum after 1 second. Now remember, this one's off a little bit. I can't take the half of the 3 to see that that is the time of the maximum height, because it is starting up at 48. Do you remember me saying that? All right, let's get busy with the next few problems. All right, I'm going to do 61 now. I have a choice of either factoring or using square root property. However, I see that all of these have an A, a B, and a C, which means I'm going to have to factor. Multiplying to give me 8 and adding to give me 6 will be 4 times 2. Both of my factors are going to be negative, equals 0. And then I have x minus 4 equals 0. That answer will give me a 4. And x minus 2 equals 0. That answer will give me a 2. So 4 and 2 are the x and y intercepts. You know what? Hold on a minute. I just realized that D said domain and range. All right, since we're talking about this type of problem, I know that the domain is the number of seconds that the ball is in the air. I can't start the time before the ball is in the air, and I can't go beyond the time that the ball is in the air. So the domain for the ball is going to be between 0 and the highest, and when it hits the ground was 0 to 3. The range is going to be from 0 to its highest point, which is 64. All right, sorry about that. Go back to 61. The answer was 4 and 2. Now 62. I need to multiply to get 6 and add to get 5, but the signs have to be different. So 2 and 3 is not going to work. I have to use x plus 6 and x minus 1 equals 0. For the first one, x plus 6, I could substitute a negative 6 in to make this equal to 0. And for the second problem, I could put a 1 in to make this equal 0. So negative 6 and 1 are my solutions for 62. Number 63, I have to move the 14 to the other side. So I have x squared minus 5x minus 14 equals 0. That gives me x, let's see here, 7 times 2, so x minus 7 and x plus 2. x minus 7 equals 0, and x plus 2 equals 0. My two solutions are 7 and negative 2. All right, this next problem, I need to figure out which graph corresponds to which of the following quadratics. I see that this opens down, so I'm going to get rid of choice A because that one opened up. My y-intercept here, well, it's definitely not negative 4. My y-intercept is not negative 4, so I'm going to take C off. My y-intercept, it looks like it's wanting it to be either 3 or 5. Gosh, that's kind of strange. Let's see here. Well, actually, if you look more carefully, this is going up by 2, 4, 6. So the y-intercept is going to be 5. So I'm also going to take off the B. Now, I'm not real sure which one of these answers is going to be correct. I can see the vertex is going to be right here on negative 1, which is the axis of symmetry. So I think I'll try negative B over 2A. So if I try it for solution D, that would be negative 4 over 2 times negative 1. Change my signs. 4 divided by negative 2 is negative 2. So, guess what? That's not at negative 1. That's at negative 2 because I'm going for 2's. All right, D looks like it might be right. Let's try E and see if it's right. I would do negative 3 over 2 times negative 1. The signs change, and that's negative 1.5. Definitely not negative 1.5. This answer looks like it's going to be D. More fun with factoring and using square roots. The only time I can use square roots is when B is 0. And it looks like none of these B's are 0. So I'm going to have to factor through all of this. Okay, starting number 42, I have to think of two things that multiply to give me 14 and add to give me 9. That is x plus 7 and x plus 2 equals 0. X plus 7 equals 0, so x is negative 7. X plus 2 equals 0, and x is negative 2. So the solutions are negative 7 and negative 2. Number 44. I'm going to go ahead and rewrite that. I see a greatest common factor, so I'm going to take out a 2. X squared minus x minus 2. Now I need to factor the inside of that. That's x minus 2 and x plus 1. Remember, when there's a number in front with no variable, that does not affect your solutions. X minus 2 equals 0. I could replace a 2 in for x to get a 0. And x plus 1 equals 0. I could replace x with a negative 1, and that would also give me a 0. So the answer to number 44 is 2 and negative 1. Number 46. I noticed that the 81's on the wrong side, so I think I'm going to move that over first. 4x squared minus 36x plus 81. Well, 4x squared is a perfect square, and so is 81. The 36 doesn't have to be a perfect square, but it is, so that's nice. I'm going to try to do a perfect square trinomial for this problem to see if it works. Since 2 times 2 gives me 4, I'm going to try the 2x as the first term. And 81 is 9 times 9. Now these two things have to multiply to give me the 81 and the 4, but they're going to have to double the middle to give me a 36. 9 times 2 is 18, and in order to double that and make it negative, this middle term is going to have to be negative, and then it equal 0. Now I've got two of the same answers, so all I have to do is solve for one of them. 2x minus 9 equals 0. I need to add 9 to each side. 2x equals 9. Divide by 2, and I get x equals 4.5. So the solution for number 46 is 4.5. All right, we're going to get busy with some word problems. Number 12, rocket is launched with initial velocity of 110. That makes the 110 go right here. The height in meters is approximated by the equation. Can you tell that the rocket here is starting from 0? Okay, so I'm going to take negative 5t squared plus 110t, and I want to know when it hits the ground. Both divisible by 5. Remember, I always tell you take a negative 5 out, and they also both have a t in common. So that gives me t minus 22. Okay, this negative 5t is going to give me negative 5t equals 0. When I divide by negative 5, I still get t equal 0 for the first answer. My second answer, I have t minus 22 equals 0. Add 22 to each side, and t equals 22. The question is about how long does it take the rocket to return into the ground, and that is going to be 22 seconds. Now, also, the halfway point of that would be 11, and that would be the time of the maximum. You could plug in the 11 to find out how high it actually went. Okay, let's do number 36 down here. We're still on number 12. The area of a square is 196. So I have a square. I don't know the sides. I'm going to call them x. The area of a square is side squared, so I have to multiply x times x, which gives me x squared, and the area is 196. I am going to use square roots to solve this one. Try to take the square root of each side, and x equals 14. Now technically I should have plus or minus 14, but since I'm talking about the area of a square, I would just say that the dimensions of the square are 14 by 14. Okay, number 47, this is a problem like we did in class a couple days ago. A rectangle is 2 feet longer than it is wide. So wide plus 2, that makes this the width. Then I have to multiply length times width. That's the formula for a rectangle, and we know that it's equal to 48. Distributing the w's, I have w squared plus 2w. I'm going to go ahead and subtract the 48 over to the other side equals 0. Now I need to factor two things that multiply to give me 48 and add to give me 2 would be 8 and 6. I want the 2 to be positive, so I'm filling in a plus 8. Now I need to solve each one. W plus 8 equals 0. When I subtract 8 from both sides, I get negative 8. W minus 6 equals 0. Add 6 to both sides, and I get a 6. Since we're talking about the length and width of a rectangle, I'm not going to be able to use the negative 8. I have to use the 6. Excuse me. I solved my equation. The dimensions of the rectangle are going to be 6 by what? Well, plug in your 6 over here. 6 plus 2 is 8. 6 by 8. All right, good job. We are cruising along. Only 2 more word problems to go. Number 14. Oh, this one's kind of irritating because there's a lot of decimals, but it's pretty easy. This is the period of a pendulum. Remember, a pendulum is like something that sits and then it goes back and forth like this. Swings back and forth one time. Here is the formula that can be approximated. The length of the period of time in seconds can be approximated by 9.78 t squared. We need to find out the period of a pendulum whose length is 60 inches. So I'm just going to take this L and change it to 60. 9.78 t squared equals 60. Divide both sides by 9.78. Now again, when we do this for your test, you are not going to have any problems that would make it difficult for you to find the answers. Everything's going to work out very nicely on these problems. So that gives me t squared equals 60 divided by 9.78 is 6.13497. And then I need to take the square root of each side. Now my solution technically should have a plus and a minus. And when I take the square root, I get 2.47689. It tells me to round to the nearest tenth, so I'm going to put 2.5. 2.5 what? Seconds. So I took the 7 and took the 4 and it rounded it up 1. Number 17, why does this have no solution, but this one has 2 solutions? Well, the graph of this x squared plus 4 is going to open up beginning at 4. Therefore, there are no solutions because it does not cross the x-intercept. x squared minus 4 is going to start down at -4 and open up. And as you can see on my graph, it has 2 solutions. All right, guys, really proud of you for taking the time to check this and doing a great job. I will be here Friday morning at 6:40 a.m. Bye-bye.